All right, so today I'd like to go over worksheet 2. And what I'm going to do is start here with the blank worksheet and show you how I used StatCrunch to create the solutions to these problems as appropriate. Uh, so we'll get into StatCrunch here in a second. But first, I want to uh, solve and calculate the sample mean for this frequency table. The frequency table is a summary of the data. It's not all of the data explicitly listed. It's simply a description by frequency table, as it's called, where we denote categories or classes. We list the frequencies, the relative frequencies, the cumulative relative frequencies for each of the classes. We also have another column up here called the midpoint, and we're going to use these midpoints to trigger the calculation of the sample mean in the following way. Notice the formula down here. X bar, the sample mean, is the sum over X, where now X is going to be this midpoint. So we'll take the product, F times X, divide by N, sum those up over the 6 classes, and that'll give us the estimate of the mean. So let's go ahead and do that. The midpoint of this class is 1, right? Because if you find the midpoint, you subtract the right boundary minus the left boundary, divide by 2. So you get a 1 here, just the midpoint, the arithmetic middle point for that interval. Now, before we go on, let me just say now what we're going to do in this formula. We don't have the 26 data values up here, do we? We just know that there were 26 values out of the 150 that fell in this range between 0 hours and 2 hours. Okay, so we don't have that data, but we're going to use 1 as a surrogate for all 26 of those data values. So remember what we do to get the mean. We add values. In this case, we're going to add 1 26 times. And then we'll add the midpoint of the next interval x, which is 3, and we'll use 3 as the surrogate for all 30 of the data points that fell in this category between 2 and 4. And then we'll multiply 30 times 3 and add. So you can see what we're doing here. We're using these midpoints as the representative value of all of the values in that particular interval. All right? And then if we take their product, x times f, and then add them all up, then divide by n, we'll get a surrogate sample mean using this frequency table. Okay? Now, in your worksheet, I've worked this all out for you, where I took the products and added them up, and I'll just give you the answer here. It was 732 divided by 150. So the sum of these products, f times x, is 732, okay? And then I divide by n, 150, and we can round that to 2 places and get 4.88. I'm using the equal sign here, but remember it's just an approximation. So 4.88 is rounded to 2 decimal places. All right, so therefore, if we'll now draw the relative frequency histogram, and we'll see that this value 4.88 is like the center of the distribution. I'll come back to that comment in a moment. All right, so I'm going to go back into StatCrunch and calculate the relative frequency histogram here. I don't need these axes anymore, so I'm going to delete them, and I'll use this space here for my new histogram computed in StatCrunch. So let's go back to StatCrunch now. And here, let me hide these results. So what I have here in StatCrunch is the following. I'm going to draw a relative frequency histogram using these 6 classes, which I input using the hyphen, 0 to 2, 2 to 4, and so on. And then in the companion column right next to it, which I've titled frequency, I've typed in the 6 frequencies for those 6 different classes. All right. Now let's go to our graph superfunction. Notice that there is a histogram function there in the list, but that function requires all of the data values. You cannot use that function if you only have a frequency table. But we do have the bar plot up here, which does allow a summary of the data, which is what we've got here in columns 1 and 2. So let's choose with summary. Look at the action window here, where we're going to select our first column, classes, which is where the categories are listed. Okay, the counts are in the frequency column here. All right, and we want to choose the relative frequency option for the type. We'll use value ascending. Notice you could use other attributes or other options here. We're going to use value ascending. We'll display the values, the relative frequency values above the bars. We'll use a basic color scheme. You can have fun, experiment with some of these other schemes. We'll go with the basic scheme. And then what's required here is to label the axes. The x-axis here now is the hours played. Okay. And then our y-axis is relative frequency. Let's put in a title here. It's optional, but we'll title it relative frequency histogram for hours played. Okay, and these 2 options here will give us a grid. Not necessary, but let's go ahead and see what it looks like. Okay, so now we compute, and now we get our graph, our plot of the relative frequency histogram for the hours played. So when you look on this plot, you'll see the axes have been labeled, the axes are scaled, and it's all done automatically by StatCrunch. The relative frequencies are given above the bars, and here you see the distribution, the so-called distribution of how the data is distributed over its 6 categories. And now 4.88 is somewhere right in here. Okay, so when you mouse over, you see that look at where that cursor is there, and you can see 4.88, which is the sample mean that we calculated in number 1, and you can see that that looks like a center point. So the mean is a measure of the center of the data. This data has a funny distribution because it's not symmetric, is it? You've got this first category, which has quite a bit of relative frequency here, almost more than 17% here. All right, so it's not completely symmetric or bell-shaped, but it does sort of follow a pattern where most of the data is centered, let's say between 4 and 6, and the mean is 4.88. as we discussed before in the first part of the problem. Okay, so now let's go ahead and copy and paste this into our document. So how do we do that? We go up to Options, and we select Copy, and then we get this new graph, and in this new graph it says Control-click the image below to copy it. So on your keyboard, go ahead and hit Control and click the mouse. You get this pop-up window, and we'll copy the image, and then we'll go back to the document and paste it right into the document. Okay, so here's our part B here, and we'll do a Command V here, and there's our histogram. Okay, now I can resize this histogram, this picture, if I want, and so on. I can center it in the document. You have a word processor at your disposal, so you can use all the bells and whistles from your word processor to format your document. Okay, so there's our histogram there. Okay, now let's go to the next problem here, number 2. In this problem, we're going to shift gears a little bit, and rather than given a set of data, we're going to generate a set of data in the following way. We're going to perform an experiment of tossing a fair coin. Fair means that there's an equal chance of heads and tails on any one toss. Or in chapters 3 and 4, we talk about probability, and we don't need to talk about probability for this problem, but you might think of the probability of the heads being 1/2. That's another way to say that there's an equal chance of heads and tails on any one toss. It's a fair coin. So let's list the possible outcomes from this experiment. First of all, we know that there are going to be 8 outcomes because there are 2 outcomes from each of the first, second, and third tosses. So to get the total number of outcomes, we would multiply 2 times 2 times 2. That's the multiplication rule that you would learn in a class in algebra discussing combinations and permutations. So there are 3 such lists, 8 such lists of 3 heads and tails. Let's go ahead and list them out here. Okay, so let's suppose we get 3 heads on 3 tosses. So that sequence is H, H, H. Or we can get a heads on the first 2 tosses followed by tails on the third toss, a heads followed by a tails followed by another heads. Okay. Or we can get a heads followed by 2 tails. All right. Okay, now I'm going to look at each of these 4 outcomes, and I'm going to simply invert heads to tails and tails to heads, and I'll get the other 4 outcomes. So here I'll write, here I'll go ahead and write tails, tails, tails. And then I'll take a look at the second box and write here tails, tails, heads. I'll look at the third box and write here tails, heads, tails. And then the last one here would be tails, heads, heads. Okay, all right, so we've got all 8 of these outcomes of tossing the coin 3 times. The second row of this table will simply count the number of heads in the outcome. In the first outcome, we've got 3 heads. In the second, 2. In the third, 2. In the fourth, just the one head. No heads there. One head here. One head here. And two heads here in the last outcome. Okay, now in number 3, we're going to look at the coin toss, and there were no heads in only one of these 8 outcomes up here. So the relative frequency of observing no heads would be 1 over 8. Similarly, for x equal to 1, we see that there are 3 outcomes here. So the relative frequency would be 3 over 8. And for 2, it would also be 3 over 8. And the first one represents the situation, let's see, the tails. Sorry, x equal to 3. Yeah, we get all h's. There's only one of those, so that's 1/8 as well. Okay, notice that the relative frequencies add up to 1. Now, we're going to use the same formula that we used in number 1 to calculate our average. So we're going to go back up to number 1. Let's copy and paste this equation here and go ahead and paste it down here, all right? So here's our function again. And we'll do the same thing. We'll take our midpoint, which we'll consider to be these values here, 0, 1, and 2, and 3. We'll multiply 0 times 1/8. We'll add 1 times 3/8, and so on. Okay? So let's do that here. So this is, and that'll give us our sample mean. So 0 times 1/8, and add 1 times 3/8, add 2 times 3/8, and finally 3 times 1/8. Okay, and so that formula gives us our estimate of the mean of this frequency table. Okay, so look at what it's doing here. You've got these values for x, 0, 1, 2, and 3. And then you might think of these relative frequencies as weights, right? The probability of no heads would be 1/8. So let's weight 0 with 1/8. You may get a 1, and that's weighted with probability or relative frequency 3/8. 2 has a relative frequency of 3/8. So this gives you a weighted average or a weighted sum. If you do the algebra and add these fractions up, you get 12 over 8, right? Okay, and we can simplify that. And I'm just going to use decimals here, 1.5. Okay, so there's our sample mean for this frequency table, and it's analogous to what we did in number 1 in calculating the mean of the frequency table there. So just one other comment, if you toss the coin 3 times, the statistical average that you would see, 1.5 heads, okay, would be called a sample mean. So here, and you might think, okay, well, if I toss the coin 4 times, is my mean 2? And it is, okay. If you toss it 10 times, your mean would be 5. And we'll get into that later when we talk about the binomial distribution. All right, so there's your solution to this sample mean calculation here. All right. Okay, now let's move on to number 4 and calculate the 5-number summary here. The 5 numbers are the min, the first quartile, the median, the third quartile, and the max. okay? N is the sample size. So what I'm going to do is go back into StatCrunch, and here you see in StatCrunch, let me clear out those results. And here what I've done is I've created another column titled Test Scores, and I've typed in each of the 22 values here from the worksheet. So this is our data. Now, what we're going to do is first use our super function stat, go down to the function summary stats like we did in worksheet 1. We're going to calculate the summary stats for the test scores column. So when we hit columns there, we get our window, our summary stats window, and we're going to choose the test scores column. We'll skip these two options here, and now we'll select N along with our 5-number summary, which is the median. So I press the Command key and click on median. We need these four now, the min, the max, and Q1 and Q3. So notice that on the right side you have the 5-number summary along with the sample size here. Okay. And now if we compute, we get our summary stats for the 5-number summary here. So let's go ahead and copy and paste these results. So that's a Control A, Control C, toggle back to the document, and I can insert that result here. So let me do a Control V, and there it is there. Okay. Now I'm going to delete this table here. We don't need that now. Okay. All right. So now we'll go ahead and construct the box plot for the data in number 4. Okay. And if you didn't have StatCrunch, you could use this 5-number summary to calculate your box plot, and many of you did it that way. You used pencil and ruler, and with these 5 values that you calculated, you were able to plot your box plot there. But let's do this in StatCrunch now. Okay. So in StatCrunch, let's hide this result. We'll use the graph super function. And if you noticed in this list, there is a box plot option here. So the box plot function will allow us to calculate our box plot. Okay, so notice that in this action window, we need to select a column. Okay, if you selected more than one column, you would get more than one box plot in your graph, but we're only plotting test scores here. Okay, and we'll skip these two options here. We'll skip the grouping options. And I don't want to identify the outliers yet, so I'll draw the boxes horizontally. The box plot will mark the median, but I want to mark the mean just to show you how that would look. Okay, and then let's go down here and use the basic color scheme. We'll label the x-axis test scores, and really the y-label, the y-axis label is not part of this graph here. There's really no y-axis mathematically. And then I'll title this box plot for test scores. Okay, and I don't want a grid necessarily, and now I'll compute, and here we get our box plot. Okay, and it's correct in the sense that it's got a label on the x-axis, and it has an optional title up here. All right, so if you were